Fantastic. Thanks, Sam, for that. And good afternoon, everyone. So my name is Kimershan, and I'm one of the co-founders and the CTO of Unibuddy. Some of you might have heard of it, some of you haven't. So I'll give you a quick introduction. So what we do at Unibuddy is we help prospective students, often in high school, to make better higher education decisions about what university to choose and where to study. And we do this by providing a chat platform and an online community platform that is embedded on university websites. And you can check more about it at unibuddy.com. But today, what I'm really here to share is the journey that started 7 years ago. And 7 years ago, I was starting my master's in computer science at UCL. And I know some of you on this call are also studying at UCL. So it's been quite a journey from scaling what started for me as a MSc project to a product that has been used around the world by over 1 million students. And today I'm going to share the key lessons from this journey with you so that you can invest in the right skills to build a successful company and hopefully to scale it as well. So I'm going to share my screen and you should see it in a few seconds. If you can see it, let me know. I'll assume it works. So today specifically, there's three areas that I'm going to be focusing on. And you've heard of some of these before, but hopefully I can provide some unique insights around each of them and you learn something new today. So one is how you can go about identifying and, more importantly, validating a problem. Second is how you can find the right solution through rapid prototyping, so also doing it cheaply and effectively. And lastly is once you have that solution that's solving your problem is how you can go about scaling this to 1 million people and beyond. And just a little disclaimer, I'll be focusing particularly on software-based products. So this is what I've worked on and what I know and I've scaled. But you can apply these principles to any business in general and to non-technical products and services as well. So let's get into it. Now, the first part you've heard millions of times before. Whenever people give advice on startups or entrepreneurships, it's all about identifying a problem. So I'm not going to spend too much time on it. But if you're a STEM student, you likely already have some valuable hard skills and you're trained to solve problems. So the mistake I often see is that STEM students rush to build things before validating it, and they often build something that nobody wants. So if you want to build a successful startup, you first need to identify a problem and validate that it's a real problem, right? And an example of this is when I co-founded Unibuddy, I was really interested in solving a problem I personally experienced. And this was moving from my home country in South Africa to the UK and feeling quite unprepared to start university in a new country at UCL, where I didn't know anyone else that was going there as well. So starting with your own problems is a great way to identify a problem to solve because you're your own customer and you can really empathize with the pain points. Now, if you can't identify a problem to solve for yourself, then you need to go out and speak to people in different industries that may have different perspectives and are in different circles than you. And in this way, you can learn about their problems and identify opportunities that you can work on. So once you've identified a problem, that's only the first part. And a lot of people get it wrong because they fail to validate the problem. And this is really important because it involves answering two questions. So firstly, is the problem big enough? A question to think about is, are you going to sell a vitamin or a painkiller? Ideally, you want to sell a painkiller because people can live without vitamins or supplements. So what's the pain are you really trying to solve for your customer? And is it a really big problem for them? And second, once you know it's a big problem, you need to understand, are there enough people in the world that see it as a problem? So if you're the only person in the world that has this problem, you don't have a market. And ultimately, you need to roughly know how many people in the world would be your customer and has this problem. So now that you have a problem to solve, this is where the fun starts, and you need to experiment until you find a solution that solves this problem. And this is what we call rapid prototyping. So again, if you're in STEM or computer science, you probably love to build things, and it's tempting to start coding immediately. But something I've learned over the years is that code is expensive. It's hard to write good code, and it's even harder to maintain it, and it's very costly. So that's where it's really useful to be aware of the cost of change curve. Now, this simply states that it's cheaper and faster to change your product or to change what's going to be built when it's in the design stage or in the requirement stage. And this is very intuitive. If you think about designing and building a house, it's very easy to make changes to it when the architect is designing it. You can add a room, you can change the layout. But if you try to change it after it's built or after the foundation is laid, it's going to be much more complex, and it's going to be much more expensive. So in the same way, until you find the right solution, you don't want to really go out and start coding and build a fully fledged app and spend lots of money on this. Instead, you want to prototype quickly. You want to focus on using designs, sketches, and no-code tools. So no-code tools have been a big rage, especially last year. And there's a whole flood of no-code tools in the market. One of them is called Bubble. You can check it out on bubble.io and play around with it. And this will allow you to create apps and services and products without actually writing any code. And you can put the app in front of users, and they can actually use it and experience your product, and then give you fast feedback, which is really what you're aiming for in the stage. So go out and experiment with no-code tools and use them. An example of what we did at Unibuddy in the early years was we showed our potential customers designs of what the platform would look like on their website. So we never built anything. We wanted to show them what it would look like and then see what they would say. So until we were confident we had found the solution, we simply kept iterating the design and showing this to customers and getting feedback and kind of rinsing and repeating. So until you're confident you found the solution, you want to use designs and you want to use no-code tools. You will be confident that you found it when your customers start to ask you, when can we use the product? Or how much does it cost? Then you can actually go out and start coding it and build it properly. Now, once you've built the solution, you want to keep iterating until you reach what's really the holy grail of any product company. And that's called product to market fit. Until you've reached this, you shouldn't invest in scaling your product, because you're most likely going to be scaling something that's suboptimal. And the question that people often are, that comes to mind immediately is, how do you know when you have product to market fit, right? And luckily, there's a simple test for this. And it's becoming really popular or more popular, and it's called the Sean Ellis test. Slack was famous for using it. And it simply involves prompting your users with a simple question and a single question, which is, how would you feel if you could no longer use our product? Now, you've reached product to market fit when more than 40% of your users say they would be very disappointed if they could no longer use your product. And until then, you should really keep iterating, keep prototyping, stick to designs, and stick to building fast and changing the product. Once you have this product to market fit and you pass the test, it's time to scale, and it's time to go big. So I'm going to focus on scaling software products again, because that's what I've done. And this is where your computer science skills are extremely critical. So the next part of this talk is a bit more technical, but again, you can apply these concepts to non-technical products as well, and think about things like bottlenecks. So looking back at the lessons we learned at Unibuddy and where we hit real roadblocks when scaling our app, I've picked out 3 computer science concepts that you really want to be aware of in order to prepare for scale. So The first one is you do want to pay attention to your algorithms class. You need a strong understanding of computational complexity, of big O notation, because at Unibuddy, we found that the first bottleneck was our database queries. Once we started to have lots of users, they started to become very slow because we found that engineers had written the code in slower than linear complexity. And as you could see with the red line, they have slower than linear. Your app starts to become very slow, even with a rather small user base or input size. So we didn't notice the slowness when we had 100 people using it. But once we started having tens of thousands or hundreds of thousands, all of a sudden the app started to become slow and users started to become frustrated. And then we had to refactor code, and that takes time and that's less efficient. So you can really avoid this, and you can scale smoothly by writing efficient code from day one. Now, the second important concept to implement is ensuring that everything is separated on your backend. This is a mistake we made at Unibuddy when we were scaling, and we found that we needed to actually make changes to things like our database or change the structure of it. So you want to make sure you follow the 3-layer architecture, isolate your code that's talking to the database. So that data access layer allows you to then change the database if you need to at later points without actually touching your business logic or the look and feel of your app. And this can also help you with making large scale changes when you're iterating and you need to change your data type or your user type as well. So 3-layer architecture, stick to this. It will really help when you're scaling. And the last concept that I just wanted to touch on is around making it easier for you to transition to microservices. Now, a lot of you that have built software would have heard about microservices, and I wouldn't recommend starting with it because the benefits of microservices only comes about after you have more than 20 engineers that are working on a team, and that's where having a single monolithic code base becomes very inefficient. So don't start by building hundreds of microservices, but you can start with building one or two, well, really 2 big services or maybe 3. And something that every app uses is user features, right? So sign up, login, user management, authentication. And something you can start with is building those 2 services, build a user service and then an app service with all the rest of your business logic. So at Unibuddy, we started with just one monolith, and we found that it was really difficult to untangle all the user-related code from the monolith later on, and it made the transition to microservices much more difficult. And a further advantage of separating out the user service is that today data protection requirements are very, very complex, and they're becoming more complex every day. So having your users' personal data stored in a separate database and isolated in its own service, that's going to allow you to implement controls, security, and meeting these data protection agreements more easily as well. And then as your company grows and your product grows, you'll be able to split out into further services, and eventually you'll have 20, 30, 100 services over time. But start with just 2 or 3 instead of starting with a single monolith or trying to do too many services. So we've spoken a lot about technical topics now in terms of scaling, just to go back. So we spoke about computational complexity, 3-layer architecture, and domain-driven design, which are all great. But it's also important to only optimize what matters. A common problem that technical students or computer science students make is a tendency to over-engineer things. And this is because what I find they do is they design for the future and then also build for the future. And then it leads to expanding the scope and taking really long to build something. So the first principle we follow at Unibuddy is design for the future, but build just for the present. And this basically means that if you think about a code base, it's a living and breathing thing. It will be refactored constantly and will evolve over time. So when you design a system, you need to try to think about how your future requirements would change and how your business will evolve, and make sure that you design it to be flexible enough to handle future changes. However, you only want to build for today's requirements, which are going to be much simpler. And this basically means you want to spend a little bit of extra time in design than you normally would, but it shouldn't make you spend more time in building because you're going to build something that's much more scoped. So when I talk about design, think about, you should visualize your box as an arrow diagram. What does a system design look like? And you spend more time thinking about how will this look perhaps in 2 years' time, or 2 years' time, or 3 years' time as well. And you want to imagine the scope and scale of what you're trying to build being much larger than today. But then when you're actually building, this might be your system design, you start building the first version, which would only be a few components of that original design. So this will really help you strike a balance between being able to build fast today, but also not ending up with a mess in the future that has to be completely rebuilt from scratch as well. So your future self would really thank you if you do it in this way. And that brings me to the end of the lightning lecture today. And thank you all for listening. And I believe we are going to go into the Q&A next.
Great. Thank you very much, Kimarsan. That was really fantastic. So just a note to our viewers, if you have any questions, please put them in the Q&A at the bottom of the screen. We do have one question. First of all, they say, hi, thank you for this delightful presentation. I would like to know, how did you convince or motivate people to provide you with constructive feedback in the early stages of the prototype or product?
Yes, it's a great question. So in our case, getting early feedback was through setting up calls with universities, because universities was our customer. That's really then becomes, how can you get your foot in the door and actually set up a call with someone at university? And we had to find, we had someone join our team, Jonathan, who'd been working in universities and higher education for 20 plus years. And that really helped us to kind of open up that black book of contacts to do it. So if you're B2B, it's a bit more difficult, and you need to find the right people in the industry that'll be willing to look at your product and give you feedback at it. And the best way to do that is to partner with someone in the industry that can open those doors for you. If you're B2C, it's a bit simpler. You have so many options today. So you have platforms like usertesting.com, where it's essentially a service that can get you get eyeballs and your target market on your product to give you feedback. And it can be on designs, it can be on survey questions, etc. You can use your own network. You can use your own friends. You can try social media advertising. So you can have a small budget and put out some ads and find people that'll be willing to give you half an hour of their time to try the product. There's a lot of different things you can do. It really depends on who your target customer is, and the narrower it is, maybe the more difficult it is to reach, but the more useful feedback you get as well. So focusing on that niche and really getting to know that customer is really important. But yeah, it really depends on B2C or versus B2B, and I can expand more on that depending on which one you're looking at.
Thank you for that. There's another question. Hi, Kimarsan, great insights. What are the learnings in scoping current needs of solutions as client want many things to be addressed, etc.?
Yeah, it's a great question, and it's a difficult problem that we still have today, even after 6 years. We have 600 universities around the world, and they're constantly requesting features, or they have new demands on the product. And how do you prioritize? So prioritization, there's a lot of different frameworks for it, but the most simplest one, and the one that we end up using a lot of the time, is really effort multiplied by impact. So if you're looking at different things that clients want addressed, one is looking at, okay, what is the impact it's going to make? So is this going to impact all your clients? and is it going to be a step change in their satisfaction, or are they going to pay more for the product with it? Or is it just something small that one client wants and that isn't going to impact other clients, right? So if the impact is small, you don't really want to prioritize that. You want to prioritize the ones that the things that are going to have the biggest impact. And the second part of that is effort. So how much of effort is it to build this or implement this? So your highest priority things should be your high impact, low effort item. So if something's very easy to build and it's going to make a big impact, you should prioritize that. Whereas things that will have a low impact and is very hard to build, you definitely don't want to be sinking time into that, because your return on investment is really low. So impact versus effort is one way you can look at that, but there's multiple frameworks that product people use in order to prioritize a roadmap for a product or a service going forward.
Thank you. Okay, we have another question. You might have touched upon the answer a little just now. This is the same person who asked the first question. So he says, thank you for your answer. One more question. You've mentioned keep it simple in the beginning, but leave room for future requirements. How do you decide that time has come to implement a particular requirement of the future?
Yes, so definitely related a bit to the previous question. I'd say again, it should be driven by your customer. So if we're talking about a feature requirement, then when you have enough customers that want it and you know it's going to make a big impact, that's when you know it's time. If you're talking about technical requirements, you should see this in your analytics. If your system is starting to reach limits at certain points, then you know that it needs those future iterations, technical versions that will help you scale. Maybe you need to add a load balancer, maybe you need to increase the number of servers, etc. So yeah, I'd say it should be always driven by the data, technical requirements. Even with technical requirements, you don't just build it because it's cool, but you build it because it's having a business impact and it's going to drive forward an objective or solve a problem for the customer. So I'd say, yeah, always have your business impact hat on, even if you're looking at technical requirements and these cool things you want to implement. Only do it if you can show the impact that it will have on your top line, and you can explain it to non-technical people. That's a great test. If you're making a technical change, can you explain the impact to non-technical people? Otherwise, you might not be adding value.
Thank you. Another question. When looking to build an application, how do you decide on platforms, for example, web or app-based, cloud, processed, or otherwise?
So yeah, great question. I think, again, this one should be dictated by your validating the problem. So when you validate the problem, you should have an idea of where people are experiencing this problem, and that should give you some idea of where you should start building a solution. So you want to go to where your customers are. If you're solving a customer's for a user group that isn't comfortable using mobile apps, then don't build a mobile app. If you know that 80% of your users, for example, are using desktop computers, then you want to build a web app. So one is go where your users are. It's very difficult to bring users to where you are going if they're not already there, and then you have to spend a lot of marketing. So yes, it should be driven by your problem validation and then also your rapid prototyping phase. So if you put something in front of a user and they tell you like, hey, I wouldn't know how to use this, or I don't use this platform, then that's good feedback, and then you should go back and prototype something else on another platform. So part of rapid prototyping is also validating and identifying what's the right platform or what's the right thing to build, and where to build it as well.
Thank you. Okay, we're nearly coming to the end of this session of Spring into STEM. However, there is one more item in the chat. So if there aren't any other pressing questions after this will be our last. So they say, if people like to over-engineer, what are broad learnings re-architecture?
Yes, so it's often engineers in any company, they do want to build a perfect system. But what my learnings over the years is that if you try to over engineer and over architect, you can end up being caught up in analysis paralysis, and you end up having these endless design meetings, architecture reviews, endless debates about which one's better, and you end up letting perfect be the enemy of good. So it's really, I think, a balance in terms of allowing for that debate and that analysis, but at some point you gotta make a decision and go for the first version and then adjust from there. So I think it's better to get something out that's decent and then to iterate quickly versus debating and not taking action and getting caught up in analysis paralysis. So yeah, my learnings from architecture is don't let perfect be the enemy of good. And there's never going to be a perfect design, and you will just make it less worse over time, really, and that should be your goal.
Great. Well, thank you, Kaimashan, for that really interesting session. I think that is going to we'll have to bring this to a close now. But thank you once again, and thank you to everyone who attended. I hope it served as some inspiration for the future. So yeah, we will leave it there. Thanks once again, everyone, for coming.
Right. Thanks, Sam. Thanks, everyone.